Now, to start chapter 6, this is all about exponential functions, which means, like as you can see in the title here, we have growth functions and decay functions. So, in this section, we're really just kind of getting used to what those look like. How do you know the difference between them? And then how to use them in money equations like interest. Okay, so let's go ahead and get started. We're going to be on page 156. If you will make sure you're there, please. Nope, I'm sorry. I take that back. 154. We're going to start with this exploration part. And really all it has you do is match these graphs that are at the bottom, A through F. It's matching it with the functions. And so as you'll notice, like these ones, I'll kind of give you a little bit of the lesson here already. These ones all have the base here is a number larger than 1. In that case, what happens is we have a growth function. So up here, it's a growth and decay. So that's when you have a growth. When you have something like in these, D, E, and F, they have a number that's between 0 and 1. That means like a fraction. That is going to be a decay function. So basically, it's like the rate at which it grows or the rate at which it decays. Okay, so let's kind of talk about the graphs of these for just a little bit. I'll take A here, and let's look at an XY chart for this function. If I plug in 0, I'm going to have 2 to the 0. Well, anything to the 0 power is 1. So that means my graph is going to have to go through the point 0, 1. Now, if you think about it, that's going to be the case for all of these, right? Because in B, 3 to the 0 is 1, 4 to the 0 is 1, 1/3 to the 0 is 1. Same thing here, to the 0 is 1, to the 0 is 1. So all of my graphs are going to go through the point 0, 1. All right, then what I'm going to do to know the difference between certain growth graphs and certain decay graphs is what happens when I plug in 1. Okay, so when I plug in 1 into this function, I get out 2. 2 to the 1 is just 2. And so I'm looking for one that goes through 1, 2. So my graph's going to look something like this so far. Okay. Now on the other side of that, what if I plugged in a negative 1? Well, then now I've got 2 to the negative 1, which is 1 over 2. And if you think about all the negative numbers that I plug into that, they're just going to get smaller and smaller and smaller, 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 smaller fractions, but they're never ever going to be 0, and they're never ever going to be negative. So what we have is something, actually this graph A matches graph A down here. So here's what I mean. So you can see my points that I plotted if I plugged it into the function. But then as you notice, this graph is going to go forever this way. And then towards negative infinity, though, what's happening is it's getting closer and closer and closer to 0, but it will never actually be 0. So what do we call that is this line called an asymptote. Like this. So it's like an imaginary line that's in the graph that says it gets closer and closer and closer and closer, but it never actually touches or crosses that graph. Okay, so that's kind of like the overview of what we're doing. So let's just talk about D real quick. In this case, you would have obviously the point 0, 1. It's going to go through, but then if I plug in 1 into that function, I'm going to get out 1/2. So now I'm looking for something that's at 1 and 1/2. So let's see. So at 1 and 1/2, I would say that is this one, D. I'd say that's about at 1 and 1/2, 0, 1. And then notice what's happening here. Now the graph is decaying, which should make sense. Again, I still have that asymptote though, because I have this graph will never ever be 0 and it will never ever be negative. It just flip-flops around the y-axis. That's the difference between a growth and a decay. Okay, so let's move on to the rest of the lesson then. If you'll just turn your pages to 156 and let's write a little bit of this down so it makes sense. Okay, an exponential function is always in this form. It's y equals, or as you know, f of x, that means the same thing, equals a, which is an initial amount, b to the x. Okay, so in all of these, a just stands for what you start with, the amount that you start with. B is going to be a rate of some sort, or yeah, they use a B because we look at it as a base. And so I could write it also like this, which means the same thing. So you just learned in the last test, some of you, that f of x just means y. So it's just like the name of the function. Okay, an exponential growth rate would look like this. Y equals a times b to the x, but where b is greater than 1. That's the important part. So numbers like 2, 3, 4, 5, whatever. The factor to that would be whatever b is. So we'll show you some examples of that. The asymptote we talked about is that line, imaginary line. This growth graph right here will never ever touch it. It just gets closer and closer and closer, but never touches. And then the decay graph or function looks like this. It's still ab to the x, but in this case, b is between 0 and 1. That means it's some fraction that's less than 1. So my decay factor would be b again. Okay, being a fraction. And that's basically, if you'll keep reading through the core concepts, that's basically what this says. It says, hey, here's my growth function. Y equals b to the x is how I know what it is. And b has to be greater than 0. And so they're just kind of explaining here with this graph exactly what I did on the previous page. Feel free to read through it if you need to. And so something I want you to add down here in the notes section of this is this function, where just because we're going to be using this in a little bit. So where this growth right here, since I said it had to be larger than 1, that's how we're going to figure out what our rate is. All right, so for right now, just write it down and we'll come back to it later. All right, page 157, this is where they talk about, hey, your decay functions, same setup, but we're going to be between 0 and 1 this time. Again, that's what this graph is showing you, is that you have a function where as x increases, the y values decrease. That's all that means. So down here in the notes, I want you to add y equals a times 1 minus r this time to the t. Okay, and we'll look at how to use that in just a little bit. Okay, and the last thing in this section that I want you to get good at is called using this formula to work out compound interest. This is probably one of the most things that we do that you actually will use in the real world. And so it has to do with taking a certain amount of money, which, so in this case, it tells you that the principal, P, this stands for the principal amount of money. And then it's 1 plus R. R is always the rate, which they have to tell you. So the rate R, compounded n times per year. So this is kind of like how they figure out your car payments. They take the amount you bought the car for, how many years you're going to finance it for, and then the times of year is going to be 12 because you pay it every month. Okay, so let's write some of those down so that you know what the ends are going to be. So you could have one that says quarterly. Quarterly means 4 times a year. Semi-annually means twice a year. Monthly, which is like how I said they do car payments, monthly is going to be 12. So N stands for the number of times a year. Another one you might see is daily, and daily is 365. That means every single day this money is being compounded with interest. All right, and then the last variable here was T, and T is always in years. Okay, so now let's put all this together and see what the questions are going to be asking us. All right, so on our next page, page 158, let's work through some of these examples. Okay, so first thing I want you to do is pause the video, and I want you to just say, from what you've learned so far, are each of these going to be a growth or a decay? Okay, pause the video and then set it back when you are ready to check. All right, this first one should be a decay because it's less than 1. Then we're going to have a growth. 3 is also going to be a growth. Now, wait a second, Ms. Hunt. You told me that if it was a fraction, it was going to be a decay. However, this fraction is 7 over 2, which is improper. 7 divided by 2 is just 3.5. That means it's larger than 1. And this number 4 is also going to be a decay. And then, so what they want you to do is to graph this. So really quickly, I'll just show you a couple of them. The rest of them are basically the same. So here, remember we have 2 points. We have the point 0, 1, because when I plug in 0 into that, I get out 1. Then I'm going to plug in 1 and I get out 1/12. Well, 1/12 is going to be really hard to graph. So I'm just going to put it kind of like right there. And then I already know that this is going to be, well, let me do a point. There we go. I already know that this is going to be a decay graph. Now, if I wanted to plug in -1, I could. And if I plugged in -1, that would mean I'd have to flip it, which would make it 12. So at -1, I'd be way up here at 12 somewhere. So that's kind of what my graph is. All right, and then the same thing, we'll just do this one growth one as well, just so you kind of get the idea. Again, 2 points. I have the point 0, 1. And if I plug in 1 into that, I get out 1.5. So I need to be at about 1.5 like that. I know this is a growth function. Bam. Okay, now the other two are going to look very, very similar to those. It's just that second point is going to change. Okay, so now you'll have lots of questions like this in your practice. Let's make sure we understand it. What they're doing is they're giving you a model of some sort, and they want you to basically break that down. So according to what we learned in our notes, where we said that this is the equation of an exponential function, A stands for what you start with. So in this case, we're starting with 100, let's see, 100 something, number of bacteria and thousands. So 100,000 bacteria pieces. I don't know what that's called. And then B is going to be our either growth or decay rate. Okay, so what does it want me to do? It says, first of all, just tell whether this is a growth or a decay. So if you know enough about this already, 1.99 is larger than 1, which means it's going to be a growth. Pretty easy. Now it says identify the hourly percent increase or decrease. So that's why I had you write down those two formulas earlier. This right here, which could also be looked at as a growth, is, oh my gosh, also looked at as a growth is the same as increasing. And then this could be looked at as a decay is the same as decreasing. I think that makes sense to you. So it's saying, well, tell me what rate that is then. So if we take this formula, we said it was a growth, so we're going to look at this one. We're going to say, okay, well then let's match it up to what they gave me. 100 goes here, so obviously 100 is my A. And then 1 plus...
Afternoon announcement. We only got one today, and that's the congratulator meeting on their victory last night against Charlotte. Junior varsity beating Charlotte 3-1, and our varsity team 6-0 win led by Brandon Long with the 93 pitch shutout. Good job, boys. Teachers, at this time, you can release the drivers, walkers, and parents.
Okay, I'm going to go ahead and finish this. I thought that I had stopped the recording, so I did. I am guilty. I did say, okay, so make it quick, because I was trying to get this done before the bell rang. So I'm just going to go ahead and pick up where we left off. All right, so we're going to match this up. So we have 100 is my A, and the 1 plus the R, the rate, in this case, would have to be 0.99, because the number there is 1.99. So obviously R has to be 99. That's where you get your percent from. So if the R is 0.99, I move the decimal 2 places to the right. And basically what we found out is that we have a 99% increase. Okay, now this part C, I'm not going to have y'all do those in this work, because that's when you learn logs is really when you can solve that. I would rather you solve it exact than an estimate like it says there. Okay, so number 6, working compound interest. So we're going to use that same formula we talked about before. So let's plug in the things that we know. So we know A equals P is the principal. It's telling me that that's 1250. And then 1 plus the rate is, now the rate is 2.25%. And I have to move the decimal back 2 places in order to use it in a formula. Okay, so then I'm going to take that divided by n. So this says compounded quarterly. So if you remember correctly, quarterly is 4 times a year. And then I'm going to raise that to the n, just 4 again, times t. T is 5 years. So I'm going to give you enough of these that you'll get very comfortable with the formula. But basically, you'll take that, plug it in your calculator. Now, when you plug it in your calculator, you do have to start on the inside. So you're going to type this part in first. I'll probably have to show you this with the calculator in class. But you'll type this in first. You'll do 0.0225 divided by 4, and then add 1 to that. Then you're going to raise that to the 20th power and then times 1250. Feel free to try that in your calculator, and let's make sure you're getting 1398.4. So we're going to take that $1,250 over 5 years at a 2.25% interest. We're going to earn, I mean, that amount that's going to be in there is going to be $1398. That means we've earned about $148 or so. Okay, let's do that to the last one here. Sorry for that. I am trying to get this done though before school ends, because I do have to tutor right now as he's knocking on the door. All right, so let me go ahead and finish this out. So we're still starting with 1250. This time though, we have our rate is going to change. We're going to use 0.0125 over n. N is going to be this time daily, which is 365. So I'm going to raise that to the n times t. Again, I'm just following the formula. Don't let this confuse you. Plug that in your calculator, and let's make sure you are getting 1330.62. Again, we will practice more of that. All right. Right now, I just want you to get an idea. If there's anything you need to go back and watch, please do that without the writing so that you can do well on the practice. All right. Have a good day and good luck. Let me know if you have any questions.